Welcome to Mr. Urton's video about dividing rational functions. I know it's a rational function, obviously, because I have a numerator and a denominator. It's set up like a fraction or a ratio. That's why it's called a rational function. And what we find is that we can treat it like a fraction. If I divide fractions, I end up multiplying by the reciprocal. So I leave the first one the way it is. X plus 5 divided by x. The second one, however, I have to flip it over or take the reciprocal. So I change it to multiplication, and when I take the reciprocal, I put the denominator in the numerator. So I'll take that x and put it in the numerator. And I will take the 3x plus 5 and put it in the denominator. I'm sorry, 3x plus 15. The second thing I'm going to do is now to simplify it. Once again, I'm going to simplify before I multiply. If I simplify before I multiply by smaller numbers. I multiply by smaller expressions as well. In order to simplify, though, I need to factor. I need to have all my factors. If I'm going to cancel a factor on the bottom, cancel a factor on the top, I need to have my denominators and my numerators factored. There's no factoring that I can do on these. I just have x. And here I have x plus 5. There's nothing in common between the x and the 5 that I can take out. But in the denominator here, I have a 3 in common. I have 3 times x plus 3 times 15. So I'm going to factor out that 3. So I have 3 times x plus 5. If you notice now, first of all, if I distribute that 3 back in, 3 times x is 3x. 3 times 5 is 15. So we know we're really just doing the opposite of distributing when we factor. But that's how we know that we can do that. We can replace 3x plus 15 with 3x plus 5. The reason we did that is now we have an x plus 5 on the bottom that's multiplied by the rest of the denominator. There's nothing added out here. My x plus 5 is multiplied by my 3. Here I have x plus 5 by itself on the numerator. So it's like x plus 5 times 1. I'm going to cancel those x plus 5s. And most of you, I think, have probably already noticed we can cancel the x's as well. I'm going to say this is like x times 1. So I'm going to replace that x. When I cancel the x, I'm going to put a 1. And to cancel that, I need to cancel an x on the bottom, so I'll cancel that x and replace that with a 1. And of course, I should have had a 1 in the numerator. When I canceled the x plus 5, that leaves me with 1. So now in my numerator, I have 1 times 1, which is 1. In my denominator, I have 1 times 3, which is 3. So my rational function, my quotient of rational functions, actually turns into a multiplication problem and then actually reduces to 1 over 3. Now try the practice problem on the second practice test, practice problem 2b.